are left in the room, we can start. So today I will talk about the state, how you can build modern web application, but not with JavaScript, but with typed alternatives. First of all, I'm not trying to raise another holy war on a subject whether you should use dynamically typed language or strictly typed. It's up to you. I'm just considering that you guys decided on your own that you want to add some types to your front end. We will look into different options that you have. We will assess them and we will compare them. We will compare them by amount of integrations and frameworks that they offer, because you cannot spell modern web without third party. We will also compare them by the size of the community, because it drives the change and the progress. And we will also check how much type flexibility do they have to offer. Our first candidate is TypeScript. It is developed by Microsoft, and it is a superset of JavaScript, which means that anything that can be written in JavaScript can be written in TypeScript. And it's compiled into JavaScript, so you can execute it. There are these kinds of pros of TypeScript. It adds type guards and type unions on top of just types. We will look into them a bit later. It also adds wide support to existing packages and frameworks. Most of the popular packages offer some typing for TypeScript. It has good IDE integration in terms that you do not need to download some obscure plugins, most IDEs supported by default. And it also allows to enrich existing data types, type definitions. So if you have some old library that you need to use in TypeScript, you do not need to write type definitions for all of it. You can go step by step enriching what you have. Of course, it has some cons, which are, it adds a step for your deployment, which is compilation. Before you did not need to do it. Now you need to compile your TypeScript code to JavaScript. Also, new features of ECMAScript take time to be transported to TypeScript, as it is a new language. So if you see some new Swedish syntax sugar, it will take around half a year till you can use it in TypeScript. Also, it adds extra layer of complexity, because on top of types, it adds some functionality which is strictly new to TypeScript, and you will need to learn about it. And if before some JavaScript dev could make a part in your team, now you need to consider people which know TypeScript as well. Our next candidate, and also we have code sample. Going top to bottom, there's an interface declaration, which is completely different from an interface you could see in Java, in terms that you do not need to implement interface. What it does, it means that any object that has name field in it is considered to be iPerson. Then we have the same thing as you would have in Java. You have method overloading, and inside method implementation, you can see iPerson pipe string. That's actually a type union, which means that any argument which is either a string or person can be passed to it. Inside if brackets, you can see type guards, which is what TypeScript adds. It checks whether the variable is a needed type. And TypeScript engine is so smart, it actually understands that inside if bracket, person or name is a string, thus allows to take the actions that we do. And inside else bracket, it understands that person or name is actually a person. Moving on to our next candidate is Flow.js. Flow.js is developed by Facebook, and it is a static type checker, which means that all it does, it just checks that you do not mess with your types. It does not have any other functionality than just adding types. Pros to it is that it's much more easier to integrate to existing JavaScript project, because all the types can be added via inline comments, so you do not break any logic. Also, it has a really flexible operator system, and it has integrations with lots of libraries and frameworks that are in JavaScript world. It also has some cons, which are, it doesn't have accessibility modifiers, but neither Vanilla.js has. It also offers less support for libraries and frameworks than TypeScript has. And it's less robust, because even though it's been developed by years in Facebook now, it's still in version 0 point something. If you're paying attention, you can see that the code sample is really similar to the ones that we would have in TypeScript, except that we have type annotation on top and a bit less code. I don't think we should run through it because we're running out of time. And this thing on the side is actually those operators that I said as ones that allow you to achieve a really extensible type system. Moving on, it's Kotlin. I'm sure lots of you heard about it. Maybe someone even writes in it. It's developed by JetBrains, and surprise, it can be compiled to JavaScript. One of its benefits is that it is Kotlin. You're probably familiar with it. You don't need to learn much of new stuff, and you get things done. And it also has some sweet nullable types. And what's more important, it offers support for type definitions from TypeScript, therefore enlarging the support for packages that it has. On the other side, it only offers integration with React. None of other front-end frameworks is supported because JetBrains only use React in their web development. They're not going to add any frameworks on their own, as they've stated in some of the GitHub issues. Also, it's a rather small community, and I mean not in Kotlin, but in Kotlin 2.js, because I'm pretty sure that no one uses it, at least not that I'm aware of, to develop web applications. And therefore, it has some gappy documentation because it's not just that popular and not that used. The code here looks just like Kotlin. Who would have guessed that? And our dark horse is Dart, which is developed by Google. It's single-threaded asynchronous language, just like JavaScript is. It runs on Dart VM, and it was supposed to have native integration with Google Chrome, but it won't. None of the browsers support Dart natively, and the idea of having it support is scrapped. It's compiled to JavaScript for browser support, and it has some pros, which are, it has really Java-like syntax. It has integrations with modern frameworks like React, Vue, Angular. It doesn't have integration with stuff like Svetlé, but it's not that much used. So, and cons of it are that it's less robust than for say, TypeScript. It has a relatively small community, because same with Kotlin, not much people use it for front end. And it's entirely new ecosystem. If before with TypeScript or Kotlin, you have stuff that you already know from Java, from JavaScript, here all the core principles are new. But it still won't take you a lot of time to learn because it's not OCaml or F#. Here's a code sample where you can see that it's pretty much like Java except for some syntax sugar and summary. And before we will proceed with it, just to remind that all the comparison is strictly biased to myself, because you don't get to say unless we get to a Q&A. So all those comparison is not absolute, it's relative. So I'm not saying that TypeScript has the biggest or the best community in all of the programming languages, but comparable to other options, it does, in my opinion. So it has better community. It does not offer that much type flexibility, but in case you need to integrate something with something, it gets things done. And if you want to learn something more about it, then I suggest that you proceed to Yakov Fein talk, which started 3 minutes ago, about front-end frameworks and TypeScript. Thank you very much, and thank you for waiting, because it was pain.